Hello students. Next two modules are on radioactivity and radioactive waste management. Radioactive materials are a special kind of materials, and special training and special management methods or special control methods are used for the radioactive materials. So, in this module we will try to understand about radioactivity and different type of radioactive waste, and in the second module we shall be talking about the different methods that are used for the management of radioactive waste. So, with this background, the learning objectives of this module are basic understanding of the concept of radioactivity, what are radioactive waste and what are different types of radioactive waste, what are different sources of radioactive waste from which radioactive materials are generated, and then how to manage the radioactive waste. When we talk about radioactivity, the concept of radioactivity was given in 1896. Radioactivity was discovered by three great scientists named as Henry Becquerel, Marie Curie and Pierre Curie. These all three were awarded Nobel Prize. Henry Becquerel, Marie Curie and Pierre Curie, they were awarded Nobel Prize of Physics in 1903, whereas Madame Curie was awarded another Nobel Prize in 1911 for the discovery of radium and polonium. Dear students, when you start studying about radioactivity, please learn about these great scientists as well as other great scientists. Those have played the major role in the development of this field of radioactivity. Now, the question arises, what is radiation? Basically, radiation is a form of energy like heat or light. This is emitted through space and matter, and it cannot be detected by any of our five senses. This is very important, because when it cannot be detected by any of our five senses, then comes the role of instruments. What I want to say is that when we study radioactivity, that time instruments are very important. Generally, nuclear radiations are transmission of energy as particles, in the form of alpha or beta particles, or as electromagnetic waves, that is gamma, from the nucleus of an atom. Or in other words, we can say nuclear radiations are emitted either as alpha particle or beta particle or gamma radiations from the radioactive materials. As far as radiation detection is concerned, as I told earlier, radiations cannot be seen, these cannot be smelled, these cannot be tasted, these cannot be felt, as well as these cannot be heard. So, here comes the role of instruments, and radiations can be detected only and only by the instruments. Dear students, I give you one small assignment that you have to do at your own level. Please make a list of different equipments that are used for the detection of radiations. Now, let me come to the radioactivity. The phenomena of spontaneous emission of radiations is called as radioactivity. Some elements like radium, thorium, uranium, these are naturally occurring radioactive materials, and some substances can be made artificially radioactive. These naturally occurring radioactive materials are called as norms, N-O-R-M or small s, means naturally occurring radioactive materials. In radioactivity, we have to understand the structure of an atom. You all know that an atom contains protons, neutrons and electrons. You all know that protons are positively charged particles, neutrons are neutral particles, and electrons are negatively charged particles. As far as protons and neutrons are concerned, they are present in the nucleus of the atom, whereas electrons are present in the orbitals and they rotate around nucleus. When the number of protons and neutrons are same, means neutron to proton ratio is equal to 1, the nucleus of an atom is considered as most stable. But when the number of protons and neutrons differ, that leads to instability of the nuclei. The unstable nuclei relaxes by the process of energy release. Means this atom nucleus, to attain stability, release energy, and this spontaneous release of energy from the unstable nuclei is called as radiation, and this phenomena of spontaneous emission of radiation is called as radioactivity. Dear student, have a look on the periodic table. Periodic table starts from hydrogen and you go up to the calcium. So, from hydrogen to calcium you will find NP ratio is equal to 1, but in the elements those are having higher molecular mass, in that case this NP ratio is not equal to 1. You please have a look on the periodic table and you will find over there the elements, or try to find out the elements in which NP ratio is not equal to 1. To understand the radiations, we should study the electromagnetic radiation spectrum. Let me have a look on the electromagnetic radiation spectrum. This figure shows the electromagnetic spectrum. Depending upon the wavelength, radiations can be divided into different type of radiations, and these are classified as radio waves, microwave, infrared, then visible, then ultraviolet radiation, then X-rays and gamma rays. In this spectrum, as we move from left to right, you will find that the wavelength is decreasing, and you all also know that there is an inverse relationship between energy and wavelength of a radiation, means if smaller the wavelength, more will be the energy. So, based upon energy, all radiation can be divided into two groups, non-ionizing radiations and ionizing radiations. What are ionizing radiations? Ionizing radiations are the radiations that carry enough energy to cause ionization of the atom with which it interact, and different type of ionizing radiations include alpha particles, beta particles, gamma particles, neutrons and X-rays. Basically these all are high energy radiations and these are very harmful to the human beings. Now, what are non-ionizing radiations? Non-ionizing radiations are those radiations that do not have enough energy needed to ionize an atom with which it interacts. And non-ionizing radiation includes radio waves, microwaves, visible light, ultraviolet radiations and infrared radiations. So, I am again repeating that non-ionizing radiations have longer wavelength, whereas ionizing radiations have smaller wavelengths. What are radioactive substances? Radioactive substances are categorized as hazardous substances as prolonged exposure to radiations emitted by radioactive substances may lead to damage or even death to the living organisms including man. The radioactive substances persist in environment for a longer period of time. The period in which radiation occurs is commonly measured and expressed as half-life. Half-life is the time required for the radioactivity of a given amount of substance to decay to half to its initial value. Let me have a look on the half-life. Let me discuss half-life little bit in detail. Radioactive half-life is the time it takes for one half of the radioactive atoms to decay to half of the original value. Half-life of radioactive materials may vary from less than a millionth of a second to millions of years. Half-life is very important parameter. With the help of this half-life, we can predict the remaining activity. If you have a look on this figure, you will find that suppose A0 is the initial amount of a radioactive material. After half-life, the material will be A0 by 2, and after second half-life period, this will be A0 by 4, and after third half-life, this will be A0 by 8, and after fourth half-life period, this will be A0 by 16, and so on. So, amount of radioactive material A compared to the original amount A0 or any quantity which is proportional to A is shown in this figure. And it is evident from this figure that radioactivity will never be 0. That is a separate issue, that radioactivity will be so low after a certain period of time that we will not be able to detect it, but it will never be a 0. Here another figure is shown at the bottom. This figure shows that suppose initially the radioactivity is like as shown on the left hand side in figure 1, and after each half-life this radioactivity will go on decreasing, and after 10th half-life there will be very little radioactivity. There are 3 naturally occurring radioactivity decay chains that are going on in this earth. One starts from uranium-238, second starts from uranium-235, and third starts from thorium-232. Dear students, please have a look on these different radioactivity decay chains, and from these decay chains you will find that some of the radioactive materials are having their half-life in billions of years, whereas some of the radioactive materials are having their half-life even a millionth of a second. And another very important thing is that all radioactivity decay chains that are naturally going on in the earth, the end product of these all is lead. Although the lead isotope may be different, in some cases this is lead 206, in some cases this is lead 208, or sometimes it is lead 210. Natural uranium is used as fuel in the nuclear power plants for energy production or electricity production. Natural uranium is having 3 isotopes. These 3 isotopes are uranium-238, uranium-235, and uranium-234. If we come to the relative abundance of different isotopes of uranium in the natural uranium is that 99.3% is the uranium-238 in natural uranium, 0.7% is uranium-235, and 0.006% is uranium-234. Dear students, in the nuclear power plants, this is uranium-235 that is used for the production of electricity, means that is used as fuel in the nuclear power plants. Please try to know that why uranium-235 is used, why not uranium-238 or uranium-234 are used, as well as I give you one small assignment. Based upon this table, you try to know the activity of 1 gram of uranium. Next important thing is the units of radioactivity. There are 2 units of radioactivity. One is Curie and second is becquerel. Curie is equal to 3.7 into 10 raised to power 10 disintegrations per minute, whereas becquerel is the 1 disintegration per second. Becquerel is the SI unit of radioactivity. Radioactivity is having a number of applications. This figure shows different fields or different applications of radioactivity. You know that radioactive materials are used as fuel in the nuclear power plants for the production of electricity. These are used as fluid fuel substitutes. These are used in water treatment. These are used for the treatment of waste. Nuclear energy is having several applications in the health sector. In health sector, radioactive materials are used in the diagnostics as well as in the treatment. Radioactivity is having number of applications in environment field also. One sewage treatment plant in India is using the nuclear energy to disinfect its sewage sludge. Once it is disinfected, then it can be used directly as manure in the agricultural fields. Radioactivity also used in the nuclear security, in other technologies as well as in the industries. Dear students, please try to know the applications of radioactive materials in different fields. This figure shows nuclear power stations in India. At present, India is having 22 nuclear reactors which are installed at 7 nuclear power stations. These nuclear power stations are Tarapur Atomic Power Station, Rawatbhata Atomic Power Station, then Madras Atomic Power Station, Narora Atomic Power Station, Kakrapar Atomic Power Station, Kaiga Nuclear Power Station, and recently the last one to this list, that is 7th one station, is the Kudankulam Nuclear Power Station. Dear student, please take a map and try to find out that these nuclear power stations are situated in which state and how many reactors are there in each nuclear power station and what is their capacity to produce the electricity. In India, about 6,800 megawatt of electricity is produced, and this is about 2 to 3% of the total electricity produced in India. When we come to the nuclear reactions, basically there are two types of nuclear reactions, and these are nuclear fission and nuclear fusion. Nuclear fission process includes that atom is divided into smaller or lighter atoms, numbering 2 or more daughters. For example, uranium-235 that is used as a fuel in the nuclear power plants, its fission take place, and when its fission take place, due to the mass defect, large amount of energy is produced, and along with that daughter radionuclides are produced, and examples of the daughter nuclides, major example are cesium-137 and strontium-90, and small amount of tritium, that is an isotope of hydrogen, is also produced. Nuclear fusion, as the name is indicating, this process takes place when small atoms, 2 or more, they join together or they fuse together to form a large or heavy atom. The best example of this is the solar energy. At sun, these hydrogen isotopes, they combine or they fuse with each other to produce the helium nuclei, and in this process large amount of energy is produced. Basically, both these processes involve the generation of energy, and that result in vast amount of energy and radioactive elements. Now, let me come to the radioactive waste. Radioactive waste are waste products which emit nuclear radiation and are contaminated with radionuclides at higher level of radioactivity or concentration beyond the established permissible limits with no anticipated use. Radioactive wastes are generated during operation, maintenance and decommissioning of nuclear and radiation facilities. These include nuclear power plants also. Radionuclides in the waste may exist in solid, liquid as well as gaseous form depending on their physical and chemical properties. As you know that radioactivity cannot be detected by any of our 5 senses. We need instruments, and in that situation radioactive waste need proper management in a safe manner to protect human health as well as non-human biota and the environment from the effects of these ionizing radiations. What are different sources of radioactive waste? There are several different sources from which radioactive waste is produced. These sources include nuclear power plants or nuclear power stations, our hospitals or medical facilities, even medicines including veterinary medicines, radioassay, clinical diagnosis, radiotherapy. They all may have radioactive materials. Then biomedical research facilities, development and labeling of radio-labeled compounds, study of metabolic processes or pathways. Over there these radioactive materials are used. Toxicological or environmental pathways of drugs, even some pesticide, fertilizers and other chemicals may include radioactive materials. Test animals when involved result in radioactive excreta, carcasses and bedding. So, there are number of sources. Clinical processes development and testing, basic research in universities and laboratories, research in nuclear centers, industry, manufacture of radioactive sealed sources, luminous devices, then electronic valves, oil exploration and well logging, quality control, water treatment, sterilization and food irradiation. So, we can say in other words, all the fields in which radioactive materials are used, over there radioactive waste is generated. Consumer products like smoke detectors and lightning rods also contain radioactive materials. Then defense is also having application, over there also some waste may be generated. Then equipments and instrument with luminous paints, gaseous, tritium light also produce some radioactive material. Then in industry the nuclear gases are used, they also produce some radioactive waste. So, dear student, please try to know where the radioactive waste is generated in the medical facilities. So, you will come to know about different type of radionuclide also, that how they are used and how the unutilized amount come to the waste. Now, let me come to the classification of radioactive waste. Based on the safety assessment for disposal site and radiological classification, radioactive wastes are classified into several classes, and these classes are exempt waste, very short lived waste, very low level waste, low level waste, intermediate level waste and high level waste. So, these are the different categories of the radioactive waste. Let me discuss them one by one. First one is exempt waste. Waste that meets the criteria for clearance, exemption or exclusion from regulatory control for radiation protection purposes are called as exempt waste. This definition is given by IAEA, that is the International Atomic Energy Agency, in 2004. Second category is very short lived waste. Very short lived waste, sometimes written as VSLW. These include waste that are short lived with short half lives. They are used in research and medical purposes. They can be stored for decay over a limited period, that is up to few years, and later these are disposed of as uncontrolled disposal. Next category is very low level waste. Very low level waste are those waste that does not meet the criteria of exempt waste and do not require a high level of contaminant and isolation, is categorized as very low level waste. They are suitable for disposal in near surface landfill type facilities with limited regulatory control. Examples of wastes are soil and rubble with low level of radioactivity concentration. If the concentration of longer lived radionuclide in VLLW are generally very limited. Next category is low level waste. Waste containing long lived radionuclides in limited amount and is above clearance level It also includes short-lived radionuclides with high concentration. These wastes require isolation and containment for periods of up to a few hundred years, and disposal of these wastes should be done in properly engineered near surface facilities. Next category is intermediate level wastes. Intermediate level wastes are the wastes that require complete isolation and greater degree of contaminant are included in this category. They contain long-lived radionuclide and emit alpha radiation. Disposal should be done at depth of the order of tens of meters to a few hundred meters. Limited or no provision is provided for heat dissipation, means that heat that is emitted by the radionuclides. Next category is high level wastes. High level wastes are long lived radionuclide and wastes that possess high levels of activity with concentration high enough to generate significant quantities of heat during the radioactive decay process are included in this category. These wastes are more harmful and hence should be disposed in deep and stable geological formation, usually several hundred meters or more below the surface. Management of radioactive waste. Radioactive waste contaminate air, water, soil and consequently vegetation that eventually affect public health and environment adversely. Or in other words, we can say that radioactivity contaminate all components of the environment. According to IAEA, the principles of radioactive waste management are protection of human health, protection of the environment, protection beyond national borders, protection of future generations, burden on future generations, national legal framework, control of radioactive waste generation management interdependencies, safety of facilities, segregation of radioactive waste. Radioactive waste should be separated or segregated according to their isotopes. You know that radioactive elements may have different isotopes. Let me take the example of hydrogen. Hydrogen is having 3 isotopes. One is hydrogen and its atomic mass is 1. Second isotope is deuterium and its atomic mass is 2. And third isotope is tritium, its atomic mass is 3. Dear students, try to find out different isotopes of some common radioactive materials or radionuclides. All other isotopes must be placed in separate containers except for tritium and C14. These two can be placed together in the same container. 10 basic physical forms of radioactive waste have been identified, and these forms are solid, glass, sharps, liquid, liquid scintillation vials. Liquid scintillation vials are used in scintillation counters, then biological, then animal remains, then source vials, lead pigs and sealed sources. Now, to summarize this module, in this module we have learnt what is radioactivity, what is half-life and how radioactivity decreases with half-life, as we know that half-life may be in billions of years or may be a fraction of a second. Then we learnt the definition of radioactive waste, we learnt about the sources of radioactive waste, we also learnt about the classification of radioactive waste and segregation of radioactive waste. In the next module, we will be again studying the radioactive waste management. I hope you enjoyed this module. Thank you.